In this video, we are going to go over the 3 tools used to create a hydro-conditioned DEM. It is an iterative 3-step process, and it is necessary to complete before you conduct any watershed modeling. Here are the 3 tools involved in the iterative editing process of your DEM. First, the Identify Impeded Flow. Second, the Visualize Flow Path. And third, the Manual Cutter and Dam Builder. Now we'll take time to go through each tool. So the first step in this iterative process is to identify impeded flows. This tool produces a valuable output showing surface depressions across the landscape. Some of these depressions are going to be real and some are not. You can see in the examples below that depressions are commonly developed behind roadways, meaning that flow will be backed up behind these. In reality, these roadways could actually be bridges or have culverts going underneath them or have ditches that would actually direct the flow under or around them. So we'll need to be editing that to allow this flow to move through. In other cases, which you can see in these examples too, there may be artifacts in the DEM shown by these smaller pink dots across the landscape. These are not true depressions and will not actually impede the flow, and we'll need to cut through those to allow the flow to continue to move. Okay, so to run this tool, we'll come over here and open it up. You can see it's very simple. We just have our one input of our unfilled DEM, so I'll come over here, drop that in, and the output gets populated, and it'll be called depth grid, followed by that 12-digit HUC. So to run it, we hit OK. Okay, so the tool is just finished running. First, let's give it some color to make it pop. We'll apply a bright color scheme, and I like to make sure that this is on from current display extent. Hit apply, OK, and we can start to see some depressions throughout the landscape. Let's zoom into a particular area, and here we can start to see where roadways are causing backup of flow. These depressions that have these flat sides that line up to these features represent that. And these, applied with the hillshade and aerial imagery, give a good idea of where you're going to need to be placing cuts. For example, along this one, I would do from the deepest point all the way across this roadway feature so it can continue to flow into this stream. Now we can start to visualize our flow paths with the Visualize Flow Paths tool. The result of this tool will be used to help with the hydromodification process. The output is a line feature that represents a flow path with a minimum area threshold set. Once that minimum threshold has been reached, the flow network begins to be delineated. The flow paths will be used in the hydromodification process to see where the lines do not line up with true existing channels. We'll know where cuts are needed or maybe dams are needed to correct this flow now. The result is visually similar to symbolizing your flow accumulation roster by classifying 2 break values. Alright, so let's go to the tool, open it up, and this tool has 3 inputs. Our D8 flow accumulation roster, our flow direction roster, and then a minimum area threshold by acres. For example, if you entered 5 acres, flow paths would be delineated from the points where 5 acres of flow has accumulated to the outlet of the watershed. The smaller the threshold, the more extensive your flow paths will be. In other words, further up in the watershed, that is where the initiation points will be. Alright, so I'm going to come over here, grab my flow accumulation, my flow direction is automatically found. You'll see that this is blanked out for now, and you'll see why in a second. So I'm going to enter 2 acres and click away, and we notice that the threshold value is preserved in the name for you right here. This 2AC represents that 2 acres. If I had chosen 2.5 acres, the value still stays 2AC. It is rounded to the nearest integer for this, since you cannot have periods in a file's name. Alrighty, so let's hit OK and let it run. Okay, so it just finished running. Here it is. Let's just change the symbology to make it stand out more. There we go. Alright, and so with this tool we can now see our flow lines before any hydro conditioning has been done. And using this output in conjunction with the impeded flow output, again our hillshade, aerial imagery, we can start to see where cut and dam lines will be needed. For example, here behind this impeded flow, we have that skating rink effect because there is no cut line across this roadway here. Alright, so we've reached the third step of the iterative editing process, and that's the manual cutter and dam builder tool, arguably the most important part in developing an accurate stream network. This tool works by the user, that's you, identifying errors within the DEM and flow network and creating cut and dam lines to correct these. As you can see in the below example, we can have errors where flow paths are not flowing in the right direction or where they're coming into or out of the watershed, which is not desired. Cut lines are used when an obstruction of flow is present within the DEM and it needs to be burned through to allow the flow to move. The way this works is a cut line is drawn, shown there in red, and then the minimum elevation value that falls underneath that line is extracted and applied to the cells all along that line. This will be used in cases where you want to show that there are culverts or maybe that flow will be going under a bridge. The second option is to develop dam lines, which are used when an obstruction to flow is desired but is absent within the DEM. In this case, when a dam line is drawn, shown there in yellow, the maximum elevation values that fall along that line will be extracted and then applied to all the cells in the DEM that line crosses. If no cut or dam lines are made, there's a good chance your flow paths are going to be inaccurate. Shown below, you can see in the DEM that the flow path should be along that dark brown line, but because no edits were made, the actual flow network that we got, shown in black, is just skating across the landscape, which is not realistic or accurate. Although it can be a tedious process, it's very important to go through the DEM one section at a time and evaluate where cut lines or dam lines should be placed very precisely. For example, it has been attempted to just apply the whole hydrologic data set to a watershed and burn that in as a cut line. However, this is going to result in inaccurate results for later tools, such as the height above channel tool used later on in the ACPF toolbox. You can see below that by burning in an entire stream network that we get false channel elevations throughout our DEM. So in the output, it's showing that every bank is 3 to 5 meters higher than the channel, where that's probably not true in reality. Instead, it's much more appropriate to apply small cut lines where they're needed and only where they're needed. So here we can see a few obstructions caused by roadways that'll need to be corrected. So we draw short and precise lines across these roadways, connecting the channel to the next channel. When you take your time and make accurate edits, you're going to get accurate results. Here's that same example shown earlier, but now the correct height above channel values are given. We have areas that are considered channel, less than 1.5 meters, and so on. To begin the process of creating cut lines and dam lines, we first need to make the feature class so we can populate them in. We'll go over to our file geodatabase where everything else is being saved to. Right-click, go down to New, and Feature Class. You want to give it a name that makes sense to you. In this case, I'm going to start making cut lines, so I'm going to name it My Cuts. Give it the same alias. Make sure you choose Line Features, and then hit Next. To make sure that we have the same coordinate system, you can set that here. Just to make sure that you are using the same one, you can go down to Layers and select that. Hit Next. Looks good, and then we hit Finish. And you can see it's automatically added into your table of contents. So now that we have that feature class in our table of contents, we can start an editing session to create our cut lines. You right-click, go down to Edit Features and Start Editing. You'll see that the Editor toolbar automatically pops up, and then we're also going to want to open up the Create Features toolbar, which you can get hitting this button right here. You want to go down and make sure that the My Cuts layer is the one that's selected. Make sure that you are creating a line, and then you can begin. You'll be able to identify areas where cut lines are needed based on that depth grid that you developed using the Identify Impeded Flow tool. So here I can see a few depressions right off the bat that will probably be drained because they're just backing up from this roadway. So what I'll do is I'll zoom in until I can start to see some of the deepest spots within these depressions, shown here in pink and on this side of the road in darker blue or purple. To create the cut line, I'm in my editing session, have selected this and line, and I simply click from the deepest point on this side to the deepest point on the other side of the road. And then I double click to end that, and then I can simply move on by panning down to the next spot and creating another cut line from about the deepest point to across the road. You'll see in this case there was no depression developed on the other side of the road, so this is where things like the hillshade and aerial imagery can be very handy. Within my hillshade, I can see that this is the channel along here, so I know to end my cut line within this channel. So you're able to see here that I've made quite a few cut lines across the landscape wherever I saw fit based on my depth grid and aerial imagery and my hillshade and the presence of roadways crossing through flow paths. One word of advice would be when you're doing this is to start in one corner of the watershed and work your way across, moving in a systematic way all the way through the watershed to make sure you don't miss spots. When you feel like you have enough cuts made, you can end your editing session by clicking on Editor, Save Edits, and there again to stop editing. And now your feature class has been saved. You can open up the attribute table and see all the cut lines that you've made within the watershed. In this particular scenario, I did not see any reason to include dam lines. However, if you did have a reason to have some dam lines within your watershed, feel free to go through the same process of creating a new feature class called My Dams or whatever you see fit, and then drawing your dam lines the same way that you did the My Cut lines. So since I'm satisfied with the My Cuts that I've made, I can start running the tool. So you come over to our toolbox, go to Manual Cutter and Dam Builder, open it up, and we can see that we have quite a few inputs and then many outputs when we run this tool. The first input is the cut lines, so I'm going to grab and drag that in there. The second one is dam lines. In my case, I didn't have any, so I'll leave it blank, but if you did have some, now would be the time to enter those. And then the third input is our unfilled DEM, and this is going to be that original DEM. So grab that, drag it in there, and then our outputs are automatically populated. You'll notice our first output is this new DEM, and this is going to be your unfilled DEM that has been hydro-conditioned using the cut lines and if you had dam lines. From here on out, if any tool asks for an unfilled DEM, you will use your new DEM. Essentially, as far as you're concerned, it is going to be replacing your original DEM since you've made all these edits. The other outputs are your filled DEM, the flow direction, flow accumulation, and hillshade rosters. These will be created using this new DEM. So essentially that D8 terrain processing is being reran with this new unfilled DEM. Alright, and finally we add our Z factor 0.01 and we hit OK, and then we sit back and wait. The reason we call this an iterative process is because once the manual cutter and dam builder tool finishes running, we'll need to go back and rerun the Identify Impeded Flow tool and the Visualize Flow Paths tool to see if the modifications that we made were enough to correct the errors within the DEM. If not, once again, we'll have to add more cut lines or more dam lines and rerun these, all three of them, again to make sure that these errors have been corrected and we have a finished hydro-modified DEM. So once the manual cutter and dam builder tool is finished running, we get our new DEM, which is shown here in the background and then also here in our table of contents. However, like I was just saying, we're not quite done yet. If we zoom into areas where we had problems previously and had made cut lines, we see that our area threshold flow network has not been adjusted yet. So this is where we'll need to rerun this tool, and we'll put in our flow accumulation roster. We'll put in the same value again, and we see that we get the same error, but that's okay, and hit all right. Once the area threshold has finished rerunning, we see that now our flow network nicely lines up to where it should be and flows underneath this road that we saw in our hill shade. We'll also need to rerun the Identify Impeded Flow tool to make sure that these get properly drained. When we rerun this tool, we're going to use this new DEM as our unfilled DEM because this is the one with the cuts burned into it, not our original one. So we'll grab this, drag it in there, and we'll be getting a new output. So now the Identify Impeded Flow tool has finished rerunning. If we turn off our new DEM and we make sure that this is on, we can see that these depressions have properly been drained, which is great. The whole process of creating cut lines and rerunning your area flow network and impeded flow may take a few tries. It's an iterative process. Every time that you run the manual cutter and dam builder tool, whether you're adding more cut lines or maybe removing some cut lines that weren't appropriate, you're always going to put in your original DEM into the unfilled DEM. And you'll be getting new outputs each time. And later tools, whenever it asks for an unfilled DEM, after you've completed hydro conditioning, you're going to be using this new DEM. This whole process may take a while, from a few hours to maybe even half a day, and that's all right. You want to make sure that you have the most accurate flow network that you can have. Here is a brief recap of everything that we went through in that iterative editing process to properly hydro condition our DEM. Now we get to move on to developing a stream network.